Welcome back to the fifth part of this video about converting continuous function into a step function. So, on our first video, of course, we have started with introducing how we can convert the linear or the real number into a step functions. So we try to use this property of h floor of x over h, wherein we can modify the desired length of h on a step function from the real number. Okay, so if we have 3 units, so we'll try to increase 3 units in every step. Okay, so this time we'll try to use the same principles of how to use the real number and convert that one into desired length of step on a step function. Okay, so but this time we'll be using already the sine, cosine, and the tangent function of trigonometric function. Okay, so let's say for example if we have the sine of x, so this is the sine function of x, that on every one period, okay, so we have a sinusoidal function. Okay, so it will try to increase every half of the pi, and every pi it will try to intersect at x line. Okay, so this time if we will try to copy and convert this sine function, we'll just rewrite. We have function of x, and we'll try to have the sine function, and then since we have the x, the real number, we'll just do the same property. So we have the h, this desired length, and then for the integer, use the floor, and for the real number, divide by the desired length of h. Okay. So now we have just made already our desired length of h. You can see that in every 1 unit it will try to move into the function. Okay, you can see if I will try to have a value of 0.2, and you can see that in every 0.2, okay, it will try to jump into the function. Okay, so the length of the step will be remain constant across the functions. Okay, so since we are having a pi right here, we can also use the pi constant. So let's say every 0.5 over pi, see that we have this function, this sine step function, okay, with the length of 0.5 unit or zero point 0.5 pi unit on the step function. Okay, and if we have other function of regular function, say we have a cos, we'll try to check for cos. Okay. Cos of x, so we'll try to change this one to cos, and we'll try to see that it will try to follow the same function. Okay, we'll try to make this one slider. Okay, like that one. Okay, so you have 0.1. Okay, we have 3. So every 3 units it will try to move on the next function. Okay, so that is for the sine and cosine, and we will also try to apply on tangent. So if we have on tangent, we have tan, and we have this is 1 to tan. You can see that we try to decrease this h. Okay, that one. So in every 0.8 length, it will try to move to the next function. Okay, so as we know that the length of this purple function will always be 0.8 because our desired length is 0.8. Okay, so that is how we try to use and convert this function, these trigonometric functions into a step functions. Okay, so we'll try to go back to sine. Okay, so sine function. Sine. We're also using sine and c. Okay. As we know that sine is also a polynomial functions. Okay, that extend infinitely many terms. Okay, so that's why uh, we can always convert any type of function into a step functions, and not only convert that one, we can also try to extend this one into the applications of calculus wherein we can also try to find the area not under the curve but also the area under the step function. Okay, so thank you so much for watching, and we'll try to end this series on this part on this video about converting the step functions. I mean converting the continuous function into step function. Thank you so much.